This is our lesson number 73 in English medium channel Sapphire Kingdom Gemology YouTube channel. In this video, we are learning sapphire heated inclusions. This is part number 2. Heated sapphire revelations, unveiling the transformation of inclusions. If you better to subscribe, give a like and share it. We are moving to lesson. We are moving to inside. Now here, lesson number 73, English medium channel, and how we identify heat treated stones. That is the main topic we are discussing. Then look at here, molten shiny cleavage surrounding this small crystal represents clear evidence that the sapphire host has been heat treated. So remember this. Okay, we are moving to inside. Here, look at the inclusions we can see here. This is the Sri Lankan sapphire. It is heat-treated sapphire. Lighting conditions. There are two lighting conditions getting together. Crossed polars plus diffuse light field. There are two lighting conditions. When we are watching these inclusions through the microscope, gemological microscope, we can see all the inclusions, and with the gemological microscope, you can use these lighting conditions which I explained in lesson number 48. All the lighting conditions are there. Under these lighting conditions, we can see the inclusions. These inclusions tell us about the sapphire, about the stone. A ghost fragment of a Sri Lankan sapphire, like a ghost, treated with high temperature, heat and pressure. Capital H, capital T means high temperature, plus capital P means pressure. These are the conditions we used for the treatment, heat treatment. The fragment shows transparent birefringent crystals. All are birefringent crystals are there. These have previously been identified as corundum used in microramen. All the crystals here are the corundum crystals. Corundum crystals inside the corundum. These small artificial corundum crystals. These corundum crystals are not the natural corundum crystals, because inside the heat treatment with pressure, all are created as natural corundum crystals. So these small artificial corundum crystals from during the heat treatment. This case first observed by the Nathan Renfro, GIA. These are called ghost crystals. These ghost crystals are created with the high temperature and pressure of the stone. First invented by Nathan Renfro of GIA, gemologist. Field of view, 4 millimeter field of view. Inside the stone, 4 millimeter length, and the 4 millimeter width is the area mentioned here. Right, we are moving to next. The same inclusions. Look at the different here. First, we discuss this. It is diffuse light field plus crossed polars. Now, the lighting condition, diffuse light field plus parallel polars. That is the only difference. Look at the difference. Diffuse light field plus crossed polars. Here, diffuse light field plus parallel polars. The same thing. Same thing. These tiny artificial corundum crystals form during the heat treatment. During the heat treatment, these artificial sapphire, artificial corundum inclusions are inside the natural sapphire, natural corundum. Firstly invented Nathan Renfro of GIA. So we are moving to next. In this, a ghost fragment of a Sri Lankan sapphire treated with high temperature and heat and pressure, HT plus P, in bright field illumination. The lighting condition is diffuse light field. It is transmitted light. Difference than earlier one. Then the field of view also 4 millimeter area, 4 millimeter length, and the 4 millimeter width area is the field of view. It is heat treated sapphire. All sapphire inclusions inside the sapphire. Inside the natural sapphire, artificial corundum crystals are there. So it is heated sapphire. What is this? The lighting conditions here is mentioned here. Fiber optic, diffuse oblique fiber optic lighting conditions shows us this picture. Look at the picture here. Heat treatment of this pink gem causes small negative crystal crystal inclusions to burst and create shiny discoid fracture around the crystals. Around these crystals, shiny discoid fractures. This is called discoids. These discoid fractures give us the evidence regarding the heat treatment. So this is heated sapphire because of this discoid, shiny discoid. We are moving to next. Here is natural sapphire, but enhancement is heat one. Ultraviolet short wave. Under the ultraviolet short wave, we can see the stone inside the stone like this. Such angular zonal lime fluorescence. Lime-like fluorescence with short wave light. So such angular zonal lime fluorescence, this is called lime fluorescence, is a sign of heat treatment. It is the sign of the heat treatment. So it gives us the clear evidence regarding the heat treated. Here, natural sapphire, Sri Lanka, but the heat treatment is heated. Lighting condition also short wave. With the short wave lighting conditions, we can see the angular zones, lime fluorescence like this or earlier one, this. There are two. Look at the chalky appearance, chalky fluorescence, lime fluorescence. We can tell it as lime fluorescence. It gives us the clear evidence regarding the treatment. It is heated. Look at this. It is under the dark field illumination. Lighting condition here is dark field illumination. This is heated sapphire from Sri Lanka. Look at the melted crystals. Look at here. Melted crystals. These crystals are melted by heat with circular heat induced bubble. This heat induced bubble make an fingerprint inside the bubble. Partially dissolved silk in heated sapphire. This is called partially dissolved silk in heated sapphire. Field of view here is 2 millimeter. That means 2 millimeter length, 2 millimeter width also 2 millimeter. That the area is mentioned here. So these inclusions tell us it is heated one. Look at this. Here the lighting condition here is transmitted light field, transmitted light. Then look at the inclusions here. The area is field of view is 4 millimeter. What is it? Unusual birefringent crystals. Birefringent crystals are there. Partially healed. Some are partially healed. low relief, partially yield fracture of sapphire treated with high temperature heat and normal pressure. When examined with micro Raman, it was proven it is heated stone, and these corundums are synthetic corundums uh, manufactured under the heat treatment. So the natural sapphire consists of synthetic corundum inclusions. These inclusions made by the heat and pressure. So it is heated stone. Look at this. The lighting condition here is diffuse light field plus crossed polars. It is also Sri Lankan sapphire, but it is heated. Look at the biofingerprint of the crystals here. So, unusual biofingerprint crystals in a low relief partially yield fracture of sapphire treated with high temperature heat and normal pressure, HT plus P. When examined with micro Raman, they proved to be corundum. It is synthetic corundum inside the natural corundum. What happened? Inside the natural corundum, it changed into synthetic corundum crystals with high temperature and pressure. It is believed that they crystallized during the treatment process. Those synthetic corundum crystals are processed during the treatment. Field of view is 4 millimeter. We are moving to next. Here, what are the lighting conditions here? Only one, fiber optic oblique. The Sri Lankan sapphire, but it is heated sapphire. You can see angular clouds. Fiber optic oblique also shows us the angular clouds in sapphires. See the angular clouds in sapphires. Such a dense texture is often a sign of high temperature heat treatment. The field of view is 7 millimeter. This shows us it is high temperature heated stone. When we move to here, what are the lighting conditions? Lighting conditions is dark field plus diffuse fiber optic. There are two lighting conditions together. And when we can view here, then what is here? These are the things we can see. This, the fingerprint inside the sapphire. But this fingerprint shows the thermal alteration. When you watch these fingerprints, you can see some alteration happens there. Watch carefully all the negative signs, negative crystals inside the fingerprint. Note the frosted dark appearance between the negative crystals, microfractures to release the pressure caused by heating. Note that each negative crystal tube has become more rounded. Each negative crystal has become more rounded as it was fallen down the neck. So that is the alteration made by the heat and pressure. So the stone is heat treated stone. We can decide it. What is there? The lighting condition here is fiber optic, diffuse, oblique. You watch this inside the cover photo when we are starting. So what is it? The molten, shiny, clear edge surrounding this small crystal represents clear evidence that the sapphire host has been heat treated. So this also heat treated sapphire from Sri Lanka. What's here? Look at the thing here. Look at the thing here. Lime short wave fluorescence. Lime short wave fluorescence. What is the condition? Lighting condition is short wave ultraviolet. So if the short wave ultraviolet shows us the lime fluorescence, it is heated. Remember that. Lime shortwave fluorescence gives us the evidence regarding the heated sapphire. It was heated. So it is Sri Lankan sapphire, but heated. See you in heated inclusions part 3. That means lesson 74E. If you haven't subscribed yet, please hit the subscribe button and also click the bell icon. You are welcome. I am stopping now. We are meeting on next lesson after 2 weeks.